Okay, so I'm looking at subdaily GPS imaging of slow slip events at the Cascadian subduction zone. Okay, so the Cascadia subduction zone experiences megathrust earthquakes on a 300 to 500 year megathrust earthquake cycle, which means that stress is building up in those years until it is released an earthquake of magnitude 8 or 9. And in the time between the megathrusts, it experiences slow movement and small release of stress called slow slip, where stress is released along the slab at depths of about 20 to 40 kilometers. So the Juan de Fuca plate is moving eastward at a rate of about 25 millimeters per year. However, it experiences periods of reversal every 14 months of about 5 to 10 millimeters. And we see this reversal recorded in both seismometers. So the tremors are recorded as seismic waves, and also in land displacement. We don't know why these reversals happen, but we know they're influenced by factors such as plate composition and slab geometry, and they occur at subduction zones. So when we're learning about slow slip, we're really learning about stress buildup and release in an active subduction zone. So GPS stations send their coordinates back to the satellite every 30 seconds. And usually when slow slip is studied, it's taken as one measurement of displacement per day. So this measurement gives insight into longer week-long processes, but not into important sub-daily processes. So we used the 30-second GPS data, but averaged into 1 hour and 3 hour, 6 hour sub-daily measurements in order to understand the amount, distribution, and timing of the reversal slip within the course of several days. And we looked at a typical slow slip event, the winter 2017 event. So using sub-daily data, we were able to measure the total displacement over the course of the event. So we see that the stations are moving southwest as opposed to their typical eastward movement. So based on these movements, we were able to generate a slip model of the subducting slab to see how much slip occurred, as well as the depth at which it was slipping. Thank you.
Great job, Elise. Questions? Okay, I have one. Was there something as you were going along that surprised you about your project?
It was really interesting to see what was happening on like the sub-daily scale. Like here, just playing around with the different time scales.
Yes, David. Thanks, Elise. That's exactly what I was curious about, is to hear a little more about when you looked at shorter time scales, if you could pull out greater resolution of that signal. You mentioned you compared different time scales of processing the data. Did you come to any conclusions on that?
I guess we were seeing movement just on an hourly scale, and it was interesting to see how much that was happening within the day. Yeah.
Thanks.
Any final? Oh, Lon has a question. Oh, you're muted though.
Thank you. Nice job. I really enjoyed that. Can you go back to your model slide, and could you just walk me through that a little bit? You were talking about the right-hand figure, which I was really interested in, but I didn't catch what this model was showing there.
So, oops, I'll go back. So, this is a model of the subducting slab. So it's showing, yes, like this slab. It's showing where the most slip is occurring. So, 2 centimeters at this depth. So we're seeing which area of the slab is experiencing the most slip during the days of March 18th through 25th.
Great. And so were you able to relate that at all to sort of the directions of slip and why the slow slip events were happening?
I guess we're seeing like the stations that move the most, like ALBH and maybe these over here correspond to like this area of the most slip. We're also seeing this, I guess, southward movement. So we're able to tell that the slip travels this way.
Great, thank you.
I'm muted. Sorry, man. I said it to you and then I did it. Jess, you have a question?
Yeah, no problem. Yeah, at least that was great. I had a question. So you said that the area of the most slip corresponded with the area kind of where the water inlet is. Do you think that that has anything, like the presence of all the water there over the plate could have anything to do with that? Or do you have any hypotheses on why that might be?
That would be an interesting thing to look into. I think there are some hypotheses about like the tides influencing slow slip because they release, I guess, the pressure on the plate. So it'd be interesting to look into that more. Otherwise, I would have to think more about the conclusion.
Okay, that's super interesting. Thank you.